Hello everybody and welcome to the video notes for Unit 7, Day 1. And Unit 7 is all going to be about exhibition practice. Today's notes are dedicated to Naomi in 6A. Hi Naomi. Let's first fill in the blanks to talk about our objective for what we're doing today. Today we will begin practicing for your exhibition project. And for the exhibition project, in science, you've already started this, you will design your energy efficient home. And then what we're going to do in math is you will use ratios to calculate the life, size, dimensions of your home. And so today we will practice using scale factors to enlarge rooms. So here's what I mean by that. Here's an example of, in science, what you're working on, and you are designing the floor plan, you're putting your rooms in your home. And on your piece of paper, right, this is 5 inches, and this right here is 5 inches. But a real home that a human would live in cannot live in a home that's 5 inches by 5 inches. It's going to be much, much larger than that. So we're going to have to enlarge. Enlarge means to make bigger. We're going to have to enlarge our floor plans. And we can do that using scale factors. So here's what I mean by that. So our kitchen, right? Our kitchen is 4 units by 3 units. 4 by 3. Here's what I mean by that, right? 4 units this way, 3 units this way, 4 by 3. And a scale factor of 2 means it's going to be 2 times as big. So I want you to write scale factor of 2 means 2 times as big. And we can set it up using equivalent ratios. So if one side of the kitchen is 4, and the other side of the kitchen is 3, we can set that up as a ratio. So 4 by 3, so the ratio is 4 to 3. Right here, right, we're just taking the 2 walls, 4 by 3. And this is going to be equal to, we're going to set up an equivalent ratio. And if the scale factor is 2, each of these dimensions is going to get 2 times as big. So that means the numerator, we're going to multiply that by 2. And to keep the ratio equivalent, if we multiply the numerator by 2, we also have to multiply the denominator by 2. So 4 times 2 is 8. And 3 times 2 is 6. So our equivalent ratio is 8 to 6. 4 to 3 is an equivalent ratio to 8 to 6. And so what we're doing is we're taking a smaller diagram that was 4 by 3, and we're using a scale factor of 2, and now it's 8 by 6. So we enlarged our diagram that was originally 4 by 3, made it bigger by a scale factor of 2, and now it's 8 by 6. All right, let's try another one together. The study is 2 by 3, and our scale factor is 3. A scale factor of 3 means we're making it 3 times as big. Let's set up our equivalent ratios. So it's 2 by 3. Our original ratio is going to be 2 over 3. 2 to 3. And this is equal to the enlarged ratio. So it's, if the scale factor is 3, that means we're multiplying the numerator and the denominator by 3. And so 2 times 3 is 6, and 3 times 3 is 9. So our equivalent ratio of 2 to 3 is 6 to 9. And we can label that over here. So we have 2 on this side, 3 on this side, and then the 2 scale factor by 3 became 6. So this side, this bigger version, this is now 6. And down here, this 3 scale factor of 3, this became a 9. So our new room, once we make it larger, is 6 by 9. With a scale factor of times 3. Okay. Now that I've done these two with you, I want you to practice these 3 on your own. And then when you're done, you can raise your hand to get your teacher check. I'm also going to go ahead and show you the first example in the daily task for today. So now I'm turning to page 3. This is your daily task, and I want to show you what you're going to be doing for your daily task after your brain break. It says to measure each rectangle in centimeters and label the diagram, then use scale factor and equivalent ratios to enlarge it. Example. Here's the original diagram. Let's use a ruler to measure it. So this side we're going to use centimeters. Is 1 centimeter. So this is 1 centimeter. And then on this side, it is 1, 2, 3 centimeters this way. So like this, 3 centimeters. The scale factor is 5, so I can set up my equivalent ratios. It's 1, 2, 3 is my original. And then in my new version, my scale factor is 5, so I'm going to multiply both the numerator and the denominator by 5. 1 times 5 is 5. 3 times 5 is 15, which means if I made this bigger, and in my new diagram, this diagram is not to scale, it would be 5 centimeters by 15 centimeters. Okay, so you're going to measure, use the scale factor with your equivalent ratios, and then relabel the diagram with the new dimensions. You're going to do that for these bottom 3 problems. And with that,